everything we knew about the solar system just 50 years ago. We got primarily from the back end of a telescope or from meteorites that fell. And when the meteorites fell and we wanted to know where they came from and what their composition was, this mission will make enormous strides answering so many questions that have come up in those 50 years.
OSIRIS-REx is a mission in NASA's New Frontiers program designed to rendezvous with a near-Earth asteroid named Bennu, survey it in great detail, select a location on the surface to send the spacecraft down to collect 60 grams or more of sample for return to Earth for analysis in our laboratories.
The challenge of finding a tag site on Bennu that met our original criteria was very hard.
But quite honestly, this team thrives on challenge. So even though we knew we had work to go, I never doubted for a moment we would solve that puzzle, that we would crack that nut, and we would safely get the spacecraft down to the surface. We had kind of expected the unexpected. This team was ready to be surprised.
3, 2, 1.
And we are live here at Lockheed Martin in Littleton, Colorado for a truly historic event. In just a few moments from now, NASA's OSIRIS-REx spacecraft is going to actually arrive at the asteroid Bennu.
Yeah, so today is what we call arrival. So when we reach 20 kilometers from the asteroid, what we're going to do is do a burn to put us into the precision flying regime that we'll be doing for the next year and a half or so in order to map and discover all we can about OSIRIS-REx and determine the best possible place to go get a sample of the asteroid and bring it back.
A little nervous, a little excited. I mean, after this burn is completed, we're going to be approximately 7 kilometers away from Bennu at the closest approach. So it's exciting, a little intimidating. There's a lot of feelings going through me right now.
It's going to be the first U.S. mission to return a sample from an asteroid. And in fact, this is going to be the largest sample return since the Apollo program brought back the moon rocks.
This is NASA's first asteroid sample return mission. NASA has had other sample return missions, most famously the Apollo program, which brought back over 300 kilograms of lunar material, which we're still analyzing today to unravel the history of the moon and the Earth-Moon system and the origin of our solar system. But there's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the daredevil spacecraft, right? We just zipped around this asteroid like a hummingbird. And it's one of the things the microgravity environment does for you, is that you can stop, you can start, you can turn left, you can turn right, you can go into orbit, you can leave orbit. You really can explore the entire near-Earth asteroid environment in exquisite detail with ultra-precision maneuvers on the spacecraft.
Bennu is about half a kilometer across, the size of a mountain. We're going to be mapping this entirely new, unexplored area of the solar system. So it's been a relatively long journey, as I mentioned, about 2 years to get out to this asteroid. So to give you a sense of a little bit of the mission timeline, OSIRIS-REx was launched on September 8th, 2016. And one of the first things we did was we did a flyby of the Earth to boost us into the right orbit to encounter the asteroid. So you see that here. We were also able to test our cameras and take a wonderful picture of the Earth as well. Today we arrive at the asteroid, and we begin a 1.5-year program to scan and study the asteroid, eventually finding a location in the summer of 2020 to touch down and acquire the sample. The sample, once acquired, is going to be put into a canister, and it's actually going to be returned to Earth. You see here TagSam putting the sample into this canister, and then in the year 2023, September 24th, this will parachute through and actually land on the Utah desert. So what we're going to do now is actually go into the mission support area here at Lockheed Martin. So how much time do we have now?
It looks like we have about 40 seconds or so before we start seeing the actual burn.
So just to remind you that we're live here at Lockheed Martin, and we are just about to arrive at the asteroid Bennu and begin proximity operations to study this asteroid, eventually returning a sample back to Earth.
Yeah, it's so exciting. I can't believe we're here. We're right there. All stations, stand by. Burn has started. Stand by for Bennu arrival. So you can see here we have the Doppler residual, so we know the burn is occurring because I'm seeing a change in velocity from the spacecraft.
It's getting very quiet in here. All right, let's just go.
We have arrived.
You may have noticed we were doing a bit of an unusual high five there. That's called the tag five, because that's reminiscent of the tag.